In this lecture, we're going to talk about a second method for solving systems of linear equations. And I call it the elimination method. It's sometimes called the method of linear combinations. It's sometimes called Gaussian elimination, right? But it all involves doing the same sequence of steps. Now, this is the method that I use when I have an equation that for some reason I cannot solve for one of the variables without bringing fractions into the process and making the whole thing kind of messy. Now, I realize with my first example here, I could easily solve either of these for x. Yes. I'm still going to use my new method. I started off with a relatively simple equation like this. I think makes it easy to see what we're doing. And then as we go along here, we'll look at some methods that you really wouldn't want to use substitution with. So what I'm going to do here really is kind of substitution related. Okay, remember one of our basic algebra principles is that I can add anything I want to an equation as long as I do it to both sides. And now remember the substitution principle says that if two things are equal, I can use them interchangeably. So here's what I'm going to do. I'm going to add negative x plus 2y to the left side of the first equation. And then I got to do the same thing on the other side, right? To keep it balanced. But on the other side, I'm going to add negative 1. And it's that substitution principle that says that's a fair play. Because at minus x plus 2y and negative 1 are equal, I can use them interchangeably. And if I do that, watch what happens. I'm literally just going to add down here. X minus x is 0x. 3y plus 2y is 5y. 1 minus 1 is 0. All right, but 0x, that's just 0, right? So this is 5y equals 0. And you see what happened, right? Really very much like what happened with the substitution method. I went from having an equation with two variables down to an equation with one, and those are easy to solve. So let's divide both sides of this by 5, and we get y equals 0. And that is, again, just like with the substitution method, that is the first half of my answer. So to find the second half, I'm going to take this value and I'm going to substitute it back into either of the other two equations. It isn't going to matter. You will get the same answer no matter which one you pick. Whereas I'm going to put it into the first one. So I'll start with x plus 3y equals 1, and we'll put 0 in here for y. X plus 3 times 0 equals 1. 3 times 0 is 0, so this is just x equals 1. And there's my other half. And now remember, right, again, we talked about this in the substitution lecture. We're not done. We have not stated the answer yet. The final answer, I'm going to bring these two together. And my final result will be 1, 0, right? And that's our solution. And of course, I didn't mention this in the last lecture, but you can check these. Take 1, 0, substitute it back into both of the two original equations, and you should see that it satisfies both of them. So here I have one that's slightly more complicated. If I try to just add these two together like I did with the last example, nothing eliminates. Right? 2x minus x, that's x. 3y plus 2y, that's 5y. No variables went away. Right? So here's what I'm going to do, though. I can fix this. I'm going to take the second equation and multiply it by 2. If I do that, this becomes negative 2x plus 4y equals negative 6. And now I'm going to leave the first one alone. I'm just going to write that over here. 2x plus 3y equals 13. Now look at what I've got. This is always my goal with this elimination method, right? I've got 2x in one equation and minus 2x in the other equation. Now I can add these together and stuff is going to cancel. This is 0. 3y plus 4y is 7y. 13 minus 6 is 7. The 0 just goes away. So this is 7y equals 7. Divide both sides by 7. Y equals 1. So all these methods end the same way. Now I have to pick one of the two original equations. Doesn't matter which. I'll take 2x plus 3y equals 13. For no other reason than it's the first one. I'll put 1 in there for y. 2x plus 3 times 1 equals 13. 3 times 1 is 3, right? So we'll subtract 3 from both sides. 2x equals 10. X equals 5. And I can combine these to get my final answer. 5, comma, 1. And we're done. So this system here is kind of our worst case scenario. Yeah, there's really no matching there. There's no one number I can multiply one of the equations from and set myself up to eliminate things. There is, but it would be a fraction, and obviously we don't want to go there, right? The whole point of this is to avoid bringing fractions into the process. So here's what I'm going to do, and I want you to just bear with me for a minute, and you'll see why I'm going to do this. I'm going to take the first equation. I'm going to go first. Your first step is to pick the variable that you want to eliminate, right? And I'm going to go for eliminating the x's. Doesn't matter which one. You can do this just as easily with the y's. So what I'm going to do is I'm going to take the first equation and multiply it by 3. All right, now where did the 3 come from? The 3 is the coefficient of the x in the other equation. Right, so if I do that multiplication, I get 6x plus 9y equals 69. Right, now I have to deal with the other one. I'm going to take this second equation and I'm going to multiply it by 2. y2, hopefully you've kind of figured it out from what I did with the first one. 2 is the coefficient of the x, again, in the other equation. All right, so let's do that and see what happens. This becomes 6x plus 4y equals 44. Now you notice I have not quite solved my problem here. If I add these together, they're not going to cancel the x's. I'm going to get 12x, not 0x. And the reason is, if you look back at those previous examples, we're always looking for a situation where we have 3x and minus 3x, 2x and minus 2x, 6x and minus 6x. Right? So what I really need is for one of these two to be negative. And to get there, I'm just going to tweak this process just a little bit. I'm going to make that a minus 2. If I do that, this becomes minus 6, minus 4, minus 44, and now I have what I need. I have 6x and minus 6x, those cancel. In the middle, 9 minus 4, this is 5y equals 69 minus 44, that's 25. Now divide by 5, y equals 5. There we go. There's our first half. Now, pick one of the other two equations. I'll use the second one this time, just to kind of prove to you there's nothing special about the first one. So if we start with 3x plus 2y equals 22, and put 5 in here for y, 3x plus 2 times 5 equals 22. That's 10, right? The 2 times 5. Subtract 10 from both sides. 3x equals 12. X equals 4. And now I can get my final answer, right? Just put the two together. This is 4, 5. Okay, so we really saw the process in all of its glory here. What we want to do is first pick a variable to eliminate. Right, so this was step 1. Then I'm going to do this switching the coefficients thing. I'm going to multiply the first equation by the coefficient of the second, and the second equation by the coefficient of the first. And if necessary, I'm going to throw a negative sign in to make sure that I get opposite signs over here. So that's step 2. Step 3 is just add them together. And step 4, that was this step here, where I substituted, right, to get the final, to get the value of the second variable for the final answer.